I am Professor Shanavas from Jamal College. My best wishes to every one of you. Today we are going to discuss about one of the important concepts of data structures, that is circular queue. Queue is a basic data structure. It is a linear list on which we can insert the elements through one end called rear, and we can delete the elements through another end called front. So in this data structure we have a drawback that after deletion of some elements through front, and if those spaces are available vacant, but we cannot store any item new. So this is a drawback. So in order to save the memory, the concept of circular queue is used, in which the rear is get connected with the front, so that we can insert item in the space which are vacant after deletion of any item. So in circular queue, how to insert an element and how to delete an element, that is what actually we are going to discuss today. Let us consider, in order to insert an item in circular queue, you have to check the condition is what is called overflow. So for overflow we have two conditions in circular queue. The first condition is that if front is equal to 1 and rear is equal to n, where n is the maximum number of elements which you can store on the queue. So in this case we consider we have 7 location, so maximum there is the size of n is equal to 7. We can store 7 elements. So if the front is equal to that is 1 and rear is equal to that is n maximum, so that means the queue is full. If it is full, we cannot store any more item, so that is the condition of overflow. Another condition is that, so after deletion, let us consider what will happen. You are inserting some more element. Let us consider this is 100 and 200. Now the rear pointer is here. Okay, front is here. What is the value of front? The front is equal to rear plus 1. Front is equal to rear plus 1. Now rear is in second location, the front is in third location. So this is also the condition of overflow. See that all the elements are full, all the elements are present in the queue. So queue is full, we cannot insert any more element. So that is also the condition for overflow. So there are two conditions. One is front is equal to 1 and rear is equal to n, and another is front is equal to rear plus 1. Okay, so now move on to the next condition is that if front is equal to null, that means what's that? The front pointer, it points nothing. If front is equal to null, then set front pointer and rear is equal to 1. You want to insert an element in which we have to, first of all we have to create the space for that. If both are null, if front is null, means that is the rear is also null. So that being the case, we have to set the value, that is front is equal to rear is equal to 1. Okay. Else, if the rear value is equal to n, the rear value is equal to n here. Okay. Now you are going to insert the element. So automatically what you have to do, you have to move the pointer rear to the first location. So you have to set rear to 1. Okay, you are going to insert the element. Okay, so that here rear is here, so you have to move the rear to the first location if rear is equal to n. Else, the normal form of normal queue operation, in which you are going to insert the element. The front is here. Now you are going to insert the next element, that is 20. So what will happen? Rear is equal to incremented by 1 and it moves. So both are here now. Okay, now rear is 2 and if you insert the third element, the rear will come to, that is third location. So every time just to simply just to increment the value of rear after, that is before incrementing, before inserting the element. So here we store the item, that is the data, in the rear of Q. So that is the rear of Q. We are storing the items 10, 20, 30. We are what's that? Storing the value on the rear of the Q. Okay. So for example, you are storing what's that? 40. Now rear will be, there is moved here. Okay. So similarly, the next this is insertion, and now as for deletion concern. So the deletion algorithm in which we are using this Q, N, front, rear, item, all these are the variables we are using in this algorithm. If front is equal to null, that means the Q is empty. If the Q is empty, we cannot delete any item. So we have to print the message, that is underflow, return. Now we are going to, that is delete an item. Okay, we are deleting item. So that is take the item from the Q, that is front of the Q, and store in the variable item. So following that, what we have to do, we have to check the condition that the front is equal to rear. If front is equal to rear, in this case, if both are, that is here, it points towards that same location, and the same data is, let us consider we are deleting this data. After deletion, once if you deleting this data, after deleted the data, what will happen? Both this F and R must be, what is that? Points nothing. So what you have to do, you have to, that is equal, you have to make the value both front and rear is equal to null. After deletion, they are pointing nothing. Okay, if both are pointing the same location, front and rear both are equal, so that being the case, you have to, that is what's that, make both the values, both the values, that is null. Else the next condition you have to check, front is equal to n. If the front value is equal to, that is n, this is the position, that is n, and the front is here. So after deletion, so what will happen? The front move to the first location. So what you have to do, set the front is equal to 1. Else it is a normal operation of the Q, as I said. See, just you are deleting the item. See, for example, we are having the values here, that is 10, 20, and let us consider the front is here. I am deleting this value. So after deletion, it moves to the next location. After deleting this value, it moves to the next location. So every time the value of the front is what's that, incremented by 1. Okay. So just I explain what is meant by a circular queue and how we can perform insertion in a circular queue and how to perform the deletion of the circular queue. I hope you understood. Thank you.